This is a very small review just because if you'll look at the one where we have the ladder and the bike rack, the SOHCAHTOA help that I gave on that, and the other video that I did in school on SOHCAHTOA, and then also the Pythagorean theorem videos, those will all help you on this test. So the story problems are covered in the previous YouTube videos, and there's a similar there is a similar triangle question that looks kind of like this. So here we have 6, 8, 10. Sorry, that's a 10. It's hard to see. So 6, 8, 10 right triangle. Here's my right angle. And then we have another triangle that they say is similar. Now this may or may not be the same lengths. Don't worry about that. The ratios will be exactly the same from the corresponding angles. So if you look at Z over here in this triangle, it corresponds to A over here. So it doesn't matter if, say, this was, say, 12, right? And then this was, say, 16, and this was, say, 24, or sorry, 20. We don't care if those are all doubled or whatever. The ratios will be the same no matter what, even if they're decimal values. So we don't care what these are. All we care about are these ratios that correspond with this similar triangle over here on the right, or on the left, sorry. So if I'm doing the sine of Z, I just want to go the side opposite over the hypotenuse. Hypotenuse is always opposite the right angle. So I'm going to do the same thing for the same values over here in this similar triangle. Because Z corresponds to A, that's where I'm going to start from. Side opposite over hypotenuse, 6 over 10, which reduces to 4 over 5. That's going to be, or sorry, 3 over 5, my bad. And that's going to be how you do it on Alex. And then you do the same thing, X, X. Okay, that corresponds to B. So I'm going to say, all right, from X or from B is the same ratio. So I want to do sine of B because B corresponds to X. So it's going to be 8 over 10, which is 4 over 5. And then tangent of X, again, X is here, corresponds to B. Tangent is opposite over adjacent, 8 over 6, which equals 4 over 3. Cosine of Z, so again, I look at Z, I look at A. Okay, so A cosine is adjacent over hypotenuse, 8 over 10, which reduces to 4 over 5. And there's one like that on the test. There's one more that might look like this, and it has a couple ways to do it. Let's say the ladder's 5 away. This is 13. There's a right angle there. It wants to know these angles. Okay, so what you'll do here is you can use Pythagorean theorem. X squared plus 5 squared equals 13 squared. That's 169. That's 25. X squared. We're calling that X. And you're trying to find like the height of the building here. So this is a ladder against the building that's 13 feet long or something like that. Very much like the one I did on there on the review video prior to this one. Anyway, I'm going to subtract 25. That's going to give me 144. X squared, square root. Obviously, X is 12 then, because it's the square root of 144. Okay, but it's also going to want to know these angles that are sitting here. Okay, so you need to have your calculator, and you need to use the second key on your calculator to do these. Okay, so I'm going to show you this because I want to do this angle. Now I can use sine, cosine, tangent, doesn't matter. I'm going to do sine, and I'm going to call this X. It doesn't matter, but I'm going to call that, or I shouldn't call that X, I guess. I should call it A because I already have an X over here. But let's say we wanted to do sine of A equals opposite over hypotenuse, 12 over 13. Or sorry, yeah, 12 over 13. Now here's the deal. I really want to know this angle. So what I do on my calculator is take the inverse sine of both sides. That's sine to the negative 1. Those will divide out, and I'm just left with angle A. So anytime, and this is important, you want to find an angle, you use inverse sine, second sine on your calculator, and then you put in the fraction value. So as I look at my calculator here, see, I have my calculator, and you'll notice this sign to the -1 right there. That's going to be second sign. So I'm going to hit second sign, and then I'm going to put in that 12 divided by 13 and close the parenthesis. Okay, then I hit equals, and it'll give me that value. Now it's going to probably say to the nearest tenth, so I'm going to round that to 67.4. Okay, so angle A in this picture is that angle right there is 67.4 degrees. So anytime you're looking for an angle, you're going to use second key, either second sine, cosine, or tangent. Now what if you'd use tangent to find that angle? Or what if we wanted to know this angle? Okay, let's say we wanted to know this angle, and I wanted to use 12 over 13 again. Let's say I just wanted to use those sides. So from this angle, what's 12? It's the side what? Adjacent. So I'm going to say, all right, to find this angle, we'll call it B, but to find that angle, if I want to use the 12 and the 13 again, I can simply use the side adjacent over the hypotenuse. So adjacent over hypotenuse is cosine of B should equal, oh sorry, I'm doing it up here. Cosine of B should equal 12 over 13. So again, just inverse cosine of both sides, cosine of the -1, those will divide out. I'm left with B, the angle measure, which is what I'm looking for, cosine to the -1 of the other side, which is inverse cosine on your calculator again. So back over to the calculator just to show you how to do it. So I want to hit second, okay, right there, second, and then cosine, which will give you the cosine to the -1. And then I want to hit 12 over 13 again. This is just from a different angle. 12 divided by 13, close the parenthesis, hit equals. That gives me 22 point, again, rounded to the nearest tenth, 6. So that angle is 22.6. Now I wanted to show you something in this triangle. Those two angles should always equal 90. If I took 67.4 and 22.6 and added those values together, notice you would get 90. Because this angle is 90, and all the angles of any triangle should equal 180, so the other two should equal 90. Because 90 plus 90 is 180. So therefore, I really didn't have to do that cosine one once I already knew one of the angles. Once you know one of the angles, the other angle is the same. The last thing I wanted to share with you is an angle of depression. So here's what an angle of depression looks like. So let's say we had an airplane flying. I don't know, we'll just draw a little X over here. So I got some airplane flying right there. This is the angle of depression. It's depressing down. So it may say, hey, it's flying at a height of 1,000 feet, okay, as it's coming into land, and this angle is 6 degrees, okay, and it says, hey, how far will the plane actually travel? Let's say this was X, okay? So if that's 6 degrees, so this is just an angle measure, sorry, and that's 6 degrees, how in the heck would I know what X is if I was only given the height of the airplane? Well, it's not hard. This is the side what? From 6 degrees, this is the side opposite. Here's the 90-degree angle right there. So I've got opposite over hypotenuse. Hey, that's the sine. So I'm going to use SOHCAHTOA every time, and I got to say, from the angle I know, what side do I know and what side do I want to know? So I'm going to say, okay, I got the sine of, now this one is 6, because that's the angle measure. Always the sine of the angle measure equals opposite 1,000 over the hypotenuse, x. Cross multiply, x sine of 6 equals 1,000. Now I want to divide both sides by sine of 6. Now here, I have 1,000 divided by sine of 6. I am not finding an angle. I'm finding a side length. When you find a side length, do not use the second key. Do not use inverse sine or inverse cosine or inverse tangent, whichever one you're doing. In this case, I'm going to use just the sine key on my calculator. So as you do look at your calculator again, I'm looking for a side length. Do not use second sine, cosine, or tangent. Just hit sine on this one. So I have 1,000, so I'm just going to punch in 1,000, divided by, and then I want to just hit sine. Don't hit second, just hit sine, because we know the angle. Sine of 6, which is the angle, close the parenthesis, hit equals. Our calculator tells us, see, there you have it, 1,000 divided by sine of 6. And it tells us that we get 9566 rounded 0.8. So, back to our thing, this side length is 9, let's make sure of that. Oh, sorry, 95, sorry, my bad, 9566.8. Okay, and that's that length, 9566.8. That's how you could do them on the test. Thanks. Bye.